Good morning, good afternoon, and good evening, everyone, depending on from where you've joined from. Welcome to today's webinar by DataPlatformGeeks. My name is Rohit, and I will be your host for today. Today's session is on Introduction to Feature Engineering, that is in machine learning. Our today's speaker is Sandip Pani, who is also our regional mentor. Satya Ramesh will be helping us with the moderation of Q&A and the smooth running of today's webinar. eDomina Systems, a lot of you already know about eDomina Systems and its popular brands. We have SQLMaestros, under which we offer advanced trainings on data and analytics, including SQL Server, data science, and whatnot. We have the learning kits, the video courses by Amit Bansal, and the unique Hands-On-Labs. I will speak about all of that a little later. We also have Peopleware in India, where we do a lot of corporate training, and a popular ERP product that is Expand SME. Last but not the least, we have DataPlatformGeeks. Yes, we have DataPlatformGeeks, of which you all are a part of. It is also one of Asia's largest data and analytics community. And under that, we have our annual conference, that is our Summit, SQL Server Geeks Annual Summit, which happened in 2015, and then in 2016. We had Data Platform Summit in 2017 and 2018. We have recently announced DPS 2019, which is happening in the month of August. So this is our theme and logo for DPS 2019, Empowering Data and AI Transformation. It will be a regular 3-day conference on 22, 23, and 24th August. And we have 3 days of pre-con this time, 19, 20, and 24. The pre-cons are already announced. There are ample to choose from. This is a pick from the last year. We had more than 1,000 attendees from more than 300 companies and over 16 countries. On the stage, you can see Rohan Kumar, the Corporate Vice President of the Azure Data Group, and his Redmond team. As I mentioned, it will be a 3-day conference and the 3 days of pre-conference training. The pre-cons are already announced. You can go ahead and register yourself. You can register for the conference as well. The Earth Super Early Bird Prize is going on right now, so please do use that. We will be having 7 tracks, more than 100+ sessions, and from 50+ speakers at the summit. One of the main reasons DPS is a popular conference is because there is 100% learning and 0% marketing. We have experts who are MVPs, MCMs, and industry stalwarts, and not to forget the Microsoft Redmond experts who are the product makers. So go ahead, visit dps10.com. Satya will be putting down the links for you to visit, and you can always write to contact@dps10.com if you have any queries. And there's a number as well if you want to reach us directly. So go ahead and book your seat today. The launch offer is going on right now. The February 2nd was the launch in Bangalore where we had done, and this is the lowest price of the summit. So go ahead and use this, and the pre-registered people have got that discount code. So if you had pre-registered, do not forget to use your discount code. So go ahead and book your seat today. And if you want to participate on behalf of your company, you can always write to us, and we will reach out to the right people in your company. So if you want us to reach out, invite your company, you can click on would you like the DPS team to invite your company. Just visit dps10.com and all the details are given there. So why should you really care about the conference? It is, if you are interested in reskilling and upskilling, this is the place for you. And moreover, there is deep technical content delivered by world's best speakers. It also gives you an opportunity to learn from one of the best people and make connections for life, of course. This summit happens at one of world's best infrastructure at Radisson Blu in Bangalore. DPS involves the community. So what does that really mean? DPS Data Platform Summit, every session that you see in DPS is being evaluated by you. You vote for the sessions that you want, and we give that sessions for you at the summit. So you learn what you choose from. So, and of course, not to forget, there is highly curated content and a disciplined execution. So next step, evaluate DPS and visit dps10.com. All our previous content is all up on the website, 2015, 16, 17, and 18. So go ahead and evaluate the summit and do join us this year. This is the DPG core team, Amit Bansal, the founder and president. We have Manohar Punna, who is the vice president, and Avnish Panchal, Vijay Mishra, Vijay Reddy, Sandip, Pani are today's speaker. Prince Rastogi, Surbi Agarwal, Sakaram Shinde, and Devdatta Nath were all regional mentors from various parts of India. These are the e-dominant teams that help us organize these events from Kolkata and Bangalore. On the stage, you can see Amit Bansal, the DPG core team, and the e-dominant team at DPS 2018 last year. Special thanks to Microsoft for supporting us in our community initiatives. So why join DPG? So all of you are already aware, we have a lot of free content up there in our website, a lot of free videos that you can use, the labs, the magazines, etc. Apart from that, we also have a regional mentor form that you can fill if you wish to be a regional mentor with DataPlatformGeeks. That will also give you an option to host meetups in your own organization. So if you want to host meetups in your organization, we can help you with that. Just write to us and fill out the regional mentor form and we will reach out to you. So if you have any questions beyond this webinar, you can always write in the Facebook, LinkedIn, and our Telegram groups. Do join those groups. Yes, all our webinars are recorded and are uploaded. All our previous webinars are up on our YouTube channel, that is youtube.com/SQLServerGeeks. They have a lot of SQL videos on our YouTube SQLMaestros channel. So visit youtube.com/SQLMaestros. Satya has already put them down. So you can visit our YouTube channels. So without any further delay, let's get started with the webinar. Over to you, Sandip.
Hey, thanks, Rohit. Just let me share my screen. Can you guys, if you can hear me, just write a yes in the comment. All right. Since you guys can hear me clear, thank you. And good afternoon, everyone. Thanks for joining today's webinar. And today's topic, as you guys know, is all about on feature engineering. So that's a very important topic. So today we'll be discussing so many stuffs about feature engineering. What is that? And also, I would like to know that how many of you have any idea on feature engineering? Just write yes if you know, and if you don't know, just write no in the comment section. All right, I am seeing a couple of Kiran, Satish, Hemant, Krishna, no idea. Very good, very good. Okay. So I hope by today's end of the session, you guys have a very good fundamental understanding of feature engineering and what is the importance of feature engineering in when you work on machine learning project or machine learning data science related projects. So this is something about me. My name is Sandip Pani and I work for Nexen Healthcare as a senior data architect. And I'm the regional mentor and the user lead for DataPlatformGeeks. Have more than 12 years of experience into data. I'm an AI/ML enthusiast. Have spoken in so many conferences, SQL Bears, Nottingham. You can, in 2015, I spoke there, and all our annual summits for DataPlatformGeeks. Earlier, it was called as SQL Server Geeks Annual Summit. So now it's become TPS. I spoke, and I also speak in various meetups and local user groups. Also, my area of expertise is into query tuning and performance optimization, and I love to talk about data. I love to write about data. I'm passionate about data, and I do blogging on below link. So that's all about me. So without further delay, let's move to the topic today. So today's agenda is we'll understand, as you said, guys, that what exactly feature engineering is and where it stands when you talk about machine learning or data science and why it is there. So we'll talk about that. Then we'll discuss a bit more on what are different feature types and what problem we face with the features and what are the different techniques to solve those problems. And then we'll have a quick demo to understand or to have a sense of feature engineering. And this session is not like deep dive because it's just introduction and it's a very huge topic. And in the industry, if you look at any data science project, specifically to the ML or AI project, the 70 to 75% of time is spent on feature engineering. And that's the one area where people has to give more importance when they start their project. The reason is, in ML, you use different algorithms. Yes, the algorithms are defined. Once you know different algorithm, you will be trying, and whichever has more accuracy or which has giving more better performance, probably you will be using that for your prediction. Or that will be keep updating based on your data get changed. Then you need to change your ML. But apart from this is quite clear or straightforward when it comes to the algorithm part. But before I reach to the algorithm, I need to make my data ready for the algorithm to consume. And that particular section is called as feature engineering. Okay. So the feature engineering, let me tell you in different definitions. So if you see all the bulleted points explain the same thing. The problem of transferring raw data into data set is called feature engineering. So if you look at your application around or the project wherever you work on, the data source are sometimes very different types, right? Sometimes you get data as a text file, sometimes from the database side, like it's in the tabular form, sometimes in the sometimes images, sometimes sounds, so sometimes big data, that's what we covered up there. And sometimes the data is just in XML form, some data are missing, some data are not accurate. Think about IoT systems. So in the IoT system, what happens? So that probably you might have multiple sensors, and certain sensors, whatever this data sends, those are like very accurate. And certain sensors, what they sense, those sensors probably may not be accurate, might be 60% accurate. So, but you collected all the data. So how do you decide that which data is good for me and which data I can utilize for my, machine learning modeling? So so those kind of stuff, when it comes, we look into feature engineering. Now, the second point, transforming data to create model input is called feature engineering. Yes, when you are creating a model, that is called the algorithm. Whatever the input you are giving to the algorithm, that particular transformation of data from raw is called as actually your feature engineering. Now look at the highlighted one, explanation. So this is, you just need to understand, if think from a layman perspective, suppose and relate to the business problem. So when somebody talk to you about a business problem, how will you understand that problem? So to understand the problem, we ask so many questions, right? Why, what, how, all this, okay? But at the end, whatever I ask, why or what and how many, where, all these are data points for me, right? Where, suppose at one place X, or what, okay, this is what happened, and when this time happened. So these are the questions, explains the problem to you. And those points are called as your data points, which is nothing but your feature. So if you explain the problem better to the systems, then system can understand the problem better. And if you can system understand the problem better, the model will be designed better. So when you look into the ML project, think about what that problem, how can I explain that problem through data points? So that is the most important thing when it comes to that. And those data points, when I find out, the process is called as feature engineering. Okay. And too much of feature engineering also, if you do, it leads to your overfitting model. So don't worry if you don't know what is the meaning of overfitting. So let me tell you quickly. If you go to the wiki definition in statistics, overfitting is the production of analysis that corresponds too closely, exactly to a particular set of data, may there fit additional data or predict future observations reliably. Bit confusing, don't worry. Let me tell you in simple form. When you design a model in a predictive model, and definitely you will be entering some data to design that model. So that model probably work fine when you, with your existing data using which you train that model. But that model will not work for unknown data. For the futuristic data, when you enter, the prediction will not be correct. So when a model works well with trained data, the accuracy is perfect, but it is not working well with your future data, with the unknown data, that model is called as an overfitting model, or the model is memorizing. So importance of feature engineering. Features directly influence the predictive model we use and the result we can achieve. So this is very important because the input, if you, the garbage in, the garbage out, we know, right? So the features, whatever the good model you use, and but if the data is not correct or is not accurate or the data is not properly feature engineered, then probably will not get the best result despite of using a good algorithm. So if the feature is flexible, then it allow you to use a less complex model. So when I'm talking about model is nothing but the output of your algorithm when you apply your data. So if the data is not clear or if data is not flexible enough, then probably you end up having a very complex algorithm to use and you have a very complex model, and that is not easy to maintain, and it will take time to execute or time to learn and time to predict. Both things will happen to that if you are using a complex model. So when it comes to ML, nowadays the aspirant data scientists who are trying to learn ML, they always think from the complex perspective of it. But it is not necessary that to design a predictive model, you need to go with always a complex algorithm. Just always starts, that is the golden line I can say, always starts with a simpler model or simpler algorithm and have a less accuracy. That's fine. You always starts with a very less accuracy and very simple model. Then you keep gradually increasing that model, make the model more complex to make it a very perfect model. So in this page, if your feature is properly designed, then probably you need not require to go for very complex model. Rather, your simple model can perform very well compared to your complex model. So better features you have, you'll get better results. So these are the certain people, what they talk about what is feature engineering is. Actually, the success of all machine learning algorithms depends on how you present the data. So this is very critical. The algorithm we use are very standard for Kaggle. So Kaggle is a site which you use at kaggle.com. If you go we used to get so many different data sets available there, and there are many competition also do within that Kaggle community. So there you can get a data set as a form of CSV. So this data is present in a CSV form, and data is not that much scattered. Probably, yes, you need to do certain kind of feature engineering, but the data is actually in the form of CSV. So it is very in standard form. But in real life, you will not get always the data in the CSV format, and it will be not in a tabular form. And you need to do so many steps to get your real features for or the correct or better feature for your algorithm. So key things to know about ML. One is feature, which is the numeric representation of raw data. Okay. Why it is only numeric representation? We have text data, we have test data, string data, what you say that. But at the end, think of an algorithm is always a mathematical formula, right? Always an algorithm is a mathematical formula, and mathematical formula always works with a number, right? So whatever we work on internally, whether you convert or you don't convert, internally everything has to convert it to a numeric data. So if you go to Python, in Python we explicitly convert everything to number, but if you go for R language, certain steps are automatically get converted to numeric. You need not require to do that. So when you are working on machine learning algorithm, always remember you need to balance between feature and the algorithm. If you're not dealing with the feature well, and then whatever the algorithm you use, probably it will not give you a better result. Or if you're using a right feature but a wrong model, wrong algorithm, then also it will not give you a better result. The idea is have your feature properly designed and start with a simple model. Gradually you will see that the feature with there is nothing called as this is a good algorithm or this is a bad algorithm. It's all about what kind of data and what's the problem we have. So at the end, you have to balance both feature and the algorithm to get the correct output or the better quality of output or better prediction. So I'm seeing some comment on here. Let me see that. Feature can be correct. Yes, of course. I'm coming to that point, Kiran. So I'll be answering, sorry, I cannot see the chat window right now. I will address all your questions at the end. Let me complete it first. So data types. So when it comes to feature, as a database developer or if you are coming from a data background, think of, just to make it simple, but not exactly it is like that, but think of a feature is nothing but a column for me. Okay. If I take it data in a two-dimensional form, and the feature is nothing but a column for me, and the whole row is called as a feature vector for me. Okay. So now when it is, if in that aspect, just to start with, you can think in that way. So in feature, you use different data types, and we have different kind of data types when you work on this. So one is numerical, one is date time, and one is categorical. Some people treat date time under categorical, but I take it in I give date time as a separate kind of features. So numerical data type, again, two types. It is divided, or you can say it is categorized into, one is discrete, one is continuous. So in discrete, what do you mean by discrete numbers? So number which you can count, okay? That's a fixed number of house you have, or whatever, how many number of house you have, how many sessions you have attended for DataPlatformGeeks, how many number of family members in your house, or how many cities you have visited so far. So those are when you get a count number, that's called as a discrete value. The continuous data type is, it can take an infinite number, which can cover your fractional number also, like house pricing, like it is a gradual number, temperature is a gradual number. So all this kind of data are called as a continuous kind of data, right? So where you can kind of cover your, your fractional number as well. Now, the other category is categorical, or the label data we say. Now, the label data, again, two types. One is nominal and one is ordinal. So nominal data has a brand, but there is no order. Remember, between nominal and ordinal, there is difference is only one, that is called as order. What is the difference? If you see the examples, you can very well relate it, like nominal data type, nationality, gender, color type, etc. So what it happens here, I cannot see the order, right? If I have a list of people, I do not have any order, that it cannot give me any sequence, like, okay, India is first or US is second or something. I just have a set of people and just I give a nationality to everyone. It doesn't reflect any kind of order for me or to the data set. But if you look at the other data set, I have a list of students and I have given a result, what they the score what they got in their exam. Some may be first class, some may be second class, some may be third class. Those are the categorized, or we labeled it, but that order also makes a difference to that, right? We can rank the data in an order, right? By order by the mark, or order by the what kind of division they got, or what kind of class they are into. So that can be grouped together. So and they where the order matters. So those kind of data is called as ordinal data type. So if you look into that, it is again, so many people have written so many blogs about it. It's people take how you interpret and how you deal with the data. This is the common data type what I talked to you. If you wanted to know a little bit more about it, I recommend you guys to read the link what I given below. And that's a very good link. There they talked about 7 different kind of data types. So I would recommend everybody to go through that link. So let's now look at certain kind of problems. So what are the different problem happens? Well, when your database, when you enter data, the obvious problem we see is that a null, right? One of the problem we face is the data. That's called as, for us, it is missing data. So how we deal with missing data, I will talk in my coming slides. And that is one of the problem. The other problem is labels cardinality. What we say is like variables with too many labels. If you have too many classes, then probably whichever having few labels, too many labels may dominate that. Okay. So particularly in your T-Brace model, where we divide the decision trees are divided based on the different groups, so that time it gets a problem. So this is just for your info. I know it might, for some of you might be, it is complex right now to understand, but I keep it intentionally so that at least you guys can explore better later stage, and you can come up with your question and you can post in Facebook. I will happy to answer those. Next one is the levels infrequent categories, which is like when you design a model in a data set, we actually split the data into two. One is trained data, one is test data, right? So with the trained data, what we do, we design the model, and with the test data, we validate that model. So particularly this approach we follow when it comes to your supervised modeling. So I'm not going to talk about what is supervised, what is unsupervised, but just concentrate what I'm covering. So in that case, think of, you are giving one scenario in the trained data to design the model, but in future, if that in the future data, suppose that test data, if you're not keeping those kind of data set, then probably cannot test it well, or think in that aspect. Data is not present in the test, but data is not present in the training, but it is present in the test. So how it can design the model? Suppose a value called X is there. Suppose think of a class called first class, second class, third class. I have data set, and when I split the data, probably in the train side, I have only first class and second class, using which I design the model, what action need to be taken and what the prediction. That's whatever the prediction based on the business problem. When I'm inputting my test data, in that only I have a called class, or class 3 or third class. And when I give that input, the model is not aware of what kind of data it is, because those kind of data is not given to training data, right? So it cannot predict what need to be done. So that is also one of the problem. That's called a level infrequent categories. And one of the most obvious problem also happens to the outliers. To know outlier detection is one of the things which you need to take care when you deal with the data set. So outlier is nothing but which actually, impact your data set. Say for example, if I'm finding out the average, okay, of one particular apartment, whoever stays, and I'm finding out the average salary of people, and whatever I get, and in that same apartment, suppose the Bill Gates stays, okay, so the overall average will get changed, but it will not give you a right picture of it, the average salary of everyone, right? Because the amount of whatever the salary earned by Bill Gates is influencing the whole average, and that's actually called as outliers. So we will talk today about missing data computation, how to deal with missing data when it comes to feature engineering. So there are 3 ways our missing data mechanism works. So we need to understand when the data is missing, why it is missing, and how it related. So we have 3 categories for that to understand it. So I have open, I think I have this research paper. So one of the research paper I will share with you guys. So I just downloaded from internet. It has very well explained about a review of methods for missing data. Go through that, and it is really helpful. So missing completely at random is one category. Where it happens, whatever data is missing, you don't know anything about that, why it is missing. It is not at all related to any of the attributes, okay? So those kind of data, those kind of missing data is called as missing completely at random. It is completely random. I don't know why this data is missing. Then the second is missing at random, MAR category. In MAR category, what is that? You can relate at least with the other attributes. Okay, this is the attribute, that's why this value is not present. The column C having this value, that's why column D is not present, right? Sometimes it happens. Suppose some column have called, active, okay? And the next column is that your deactivate date, okay? So since you see active is 1, probably because of that, deactivate column is having null, right? It's not missing, but why it is missing, at least you can relate it. Okay. Now, next comes to the missing not at random. So if you look into the data set, in the same column, certain values are missing. Maybe think about a data set where, okay, you say that Sandip has not entered this value. Okay, he's like that. He never enter he never fill the form completely. He only fills the mandatory fields. He never fills the, also probably from the business perspective, you can relate that way. And why for this person has not entered? So if it is that kind of missing is called a missing not at random. You can very well identify why it is missing in the business. So numeric features. So today we are going to cover feature engineering with only numeric feature, because the text featuring with natural language processing, those things I would like to take in future, future sessions, because those are bit, you need more, understanding about feature engineering, and but that it's a bit more complex when it comes, and it is the numeric feature engineering is more easy to understand. So like in your go to text featuring, text feature engineering, you need to think about TF, IDF, bag of words. There are different techniques, so probably we'll discuss in future sessions on this. But when it comes to numeric, now think of what do we do basically with the numeric data. We do count, or sometimes price is there, sometimes percentage is there, kind of data, it is measurement, right? Age. So these are different kind of numerical data we see in all our data sets, right? So what we can do with the number? What kind of stuff we can do with the number? What are the different things when you talk about any particular number? What is the core characteristics of a number? First is scale, right? Scale means, suppose I'm talking about age, definitely age is between 0 to 100. That might be a scale for that particular value. And the second point is the distribution. Okay, when I talked about distribution means if I have set up data with age, then I can talk about how many, what are the average age, what is the mean, or what is the standard deviation of that age. So all these things, how the data is distributed, we can find out through the numbers. We can play around it. Okay, 10 records having this value, 20 records having this value. That's we talked about distribution, right? It is equally distributed or evenly distributed. What is that? So anytime number comes, we think about these two things: scale and distribution. So now, when it comes to count, we discussed in the previous counts. Let's discuss about count. So dealing with count, there are different techniques when you deal with count number, counted values. So one of the techniques is called as binarization. Why it is needed? Well, the core quantitative feature binarization is to set a threshold. How you do the binarization is, suppose I have a result set with student having only score. Okay, score is like somebody has got the total score is 500, and somebody got 400, somebody got 300, somebody got 350, somebody got 450. But if I look into my problem, it doesn't matter a person got how much. I wanted to predict for future data a person is passed or not, right? So for me, it is important that I need to check, I need to put a threshold like, okay, if somebody crosses 250, it's a pass, he is passed or she is passed. And if somebody not crossing 250, she is failed or he is failed. So in that case, I just need a new column called result, and there I can store only 1010 based on those values, based on the score. So that kind of technique is called as your binarization. So one more technique is also called as one-hot encoding, which we will talk little later. The other kind of technique on count when you deal with the count is quantization or binning. What is quantization? So quantization and binning is nothing but a simple term called as bucketing. Okay, so bucketing is what I create different groups. So the group means probably I may create 3 groups. Okay, based on the score, the way I created past fail, probably I need a bucket called first class, second class, or third class. Probably I can create 3 buckets, or I can put number like 1, 2, and 3 to the number, but it is ordinal, right? I'm giving ordinal as well as 1, 2, 3. So anytime any number comes, any score comes, I can give a rating of a 1 or 2 or 3. That's called as binning. I'm putting a particular student to particular bucket. Okay, he is into the first class bucket, he is into second class bucket. Or think of from the age perspective. The age, I may create a group where age between 0 to 30 is in one group, young group. From 30 to 60 is a middleman or a moderate group. And then the other group I can create after 60, it is an old group. Probably 3 group I created. So based on the age, I can create this particular group. And this basically helps me to solve different kind of problem. One of the problem we face is skewness. Suppose we find so many people having age 5. Okay, so having 5, if so many people are there, if you draw the histogram, probably you can see a left skewness, that 5 having very high values, number of people. But if I create a bucket, probably those value will come under only young group, right? I given only one number called 1 or 2, so it doesn't look like skewness, and it solves the problem of skewness. So binning can be two types. One is fixed width binning, one is quantile binning. Well, what is fixed width binning and quantile binning? Fixed width binning is I given numbers, I given 4 buckets. I know these 4 buckets I need to put all my data, which group it will go. Quantile binning is based on the quantity, right? I have millions of record. I wanted to create 10 groups. So you remember we in SQL Server, if you go, we have a entile which will group 10 different groups, right? Randomly it creates. I just give a number that I need 10 groups, then it will automatically create 10 groups. I don't know how it creates it. So fixed width, I give the bucketing logic. In quantile, we just give okay 20% every data set will have 20%. That's called as quantile binning. So then go to your feature scaling. So this is one of the very important topic, and I think whatever I have done so far in my research, whenever I work on ML, I always go with this, and it has to go with. And so the two common scaling techniques are normalization and standardization. Some algorithm may not perform efficiently when the numerical features have different scales. So what do you mean by that? Now think of an example. When you go for your health check, okay, and some values when it comes to some value, when it is some values results are coming between 300, right? Some results are between 300, like 0 to 300. Some results is only between 0 to 10, because that's the scale how that's the written value is. So how will I relate a result A value is scored between 0 to 10, and other score is between 0 to 300. Okay, so is it like that if somebody got 9 in one scale, in one of the health parameter, and other one he got 250, how will you relate these two? Okay, so I need a single, it means I cannot measure both the thing in the same scale, right? So in order to compare all the data, I need to keep everything in same scale, and that time I use scaling techniques. So this PCA, KNN, K-means, all these uses the scaling technique. So scaling helps provide better mathematical properties in some algorithms, and feature scaling always divide the feature by a constant, and it does not change the distribution of the data. It means scaling will not change the distribution of your data. It will just use a different scale for all the features, or whatever the feature you wanted to do the normalization or standardization. So that technique is called as scaling, or and that we can achieve through normalization standardization. Certain different way to do that is we have different formulas, like Minmax is a formula, or one is called a Z-score is another technique to do that, and there are various techniques where we can utilize this. Sometimes we use normalization or logarithm we use to normalize the data. So now comes to standard scaling. So let's only this just for your information to explore more on that. So I would only say that in this case, when I talked about standardization, it's nothing about your Z-score, how to find out this is the formula of Z-score, what we do it. So just research on Z-score, you will get to know why it is used. And if any queries on that, just post on Facebook. I would happy to answer those questions. So as I was talking about, normalization technique, min-max scaling is one of the way where you do that. Features are scaled from 0, 1 or any other fixed range. So think of, if I give a number and I tell you that tell me this number only between 0 and 1, then how will you tell that? So if you guys have learned about sigmoid function in your school days, then probably that does the same thing. Between 0 and 1, I wanted to keep all the values. So that's another technique. So for your understanding in a different way, think of, we can represent every color between 0 to 255 with RGB color range, right? We can represent different colors. So that is also a normalization technique. So now encoding categorical variables. So we understand now that what is a categorical variable? We have nominal and ordinal, right? So suppose one value is there which is ordinal, but I don't wanted that ordinal to be impacted. Or suppose now I have 3 colors, okay? The colors are red, green, and blue. And I wanted to, whenever I get a new color, I wanted to assign to one particular bucket. Okay. So one color came, okay, I think this color is related to more closer to red. I can put in the red bucket. But when it comes to numbering, I need at the end, I need to convert them to numeric data, right? So if I give number called red to 1, 2 to green, 3 to blue, then 1 to 3 is again going as ordinal, where the data set might be biased by seeing 1 to 3. The system may think 1 means high priority, 3 means low priority, but I don't want it to do that. I don't want it, those kind of biasness should be there in my data set. So what I can do instead of that, I can create 3 columns called RGB, and based on that, I can store 0, 1, 0 or 0, 0, 1 or 0, 1, 0, 0. So wherever it comes closer, I can put it. So that way, it will not tell you that it is biased by any other column, because other 2 columns are there with you. So you only present numbers through 0 and 1. Okay. So that is called as one hot encoding or dummy encoding. The other encoding, as I said, already discussed, each category labeled as an order integer 1, 2, 3. If you wanted to go, yes, if you wanted to give priority, is that if my model should have more priority to the red color, or then the green color, then the blue color, then very well you can go with 1, 2, 3. So that kind of encoding is called as level encoding. So let's go and have a quick demo on this. So in order to do the demo, I'm using Jupyter Notebook. So let's go to the demo part. So if you look at, I'm just using, I just opened the Jupyter Notebook, and I'm using Python 3.5 kernel. So it means everything will be using the Python 3.5 version. Okay, those who are new to Jupyter, I would say go to install. There are different ways you can install Jupyter Notebook. We have Jupyter Azure also. Go to Microsoft and Jupyter Notebook services there, where you can execute all this. Or you can install locally Anaconda, where you can run Jupyter Notebook. So I'm just importing 2 here. Only I'm inserting pandas and import NumPy package. So these 2 packages I'll be using. Pandas is one of the packages which will deal with your data set to work with. Whatever the data set or data table which you create to work with, you use pandas package. NumPy is to do the all kind of matrix multiplication. It's related to numeric side of it, calculation part. And I'm also importing 2 different packages for plotting graphs, matplotlib and seaborn. And you just ignore this. This is not needed right now at this moment. So I'm going to use now the Titanic data set. So which data set is available? If you search in the internet, you can find it everywhere. I took it from Kaggle data set. And then why I'm using the Titanic data set? Because I believe everyone has little or more a domain idea about the Titanic, because we have seen the movie or have a little bit of story about that movie or the real story about it. So let's go with that. So if you see the Titanic data set, it has different columns. I given names over here, like age is a fractional if less than 1. If age is estimated, it is a form of 2.5 or 20.5, like that. So there are certain columns where you need to understand what is the meaning of it. There is a column called SIB SP. So there is a column called SIB SP, which is sibling or spouse. If you see a column in the data set, that is a sibling and spouse, if you see here. And parts is the data set defines is it a family, is it the person is traveling with family or not. So just to know that there is a column called parts. So what I did, you can go to know about the dataset details here, or you can search in the internet also, same thing, you'll find it out. So now what I did, using PD is nothing but my package of pandas. I just loaded my dataset, train.csv, I loaded into this. Now I'm just looking into 10 records. So if you see, these are my 10 records, number always starts from 0. So the 9 records I could see here, right? So if you see this, what are the different kind of discrete? We talked about discrete, continuous, nominal, ordinal, right? Let's now look at here. So numerical discrete data, passenger ID, it is discrete, right? It is, though it is continuous, but it cannot be fractional.
Hello, Sandip, sorry to interrupt. We are not seeing your demo screen. We're just seeing PPT still even now.
All right. Wait a minute. Can you see now?
Not yet. We are still seeing the same PPTs.
Okay. Okay, no problem. No problem. I can go to here. Can you see now?
Yes, now we can see Jupyter screen.
Okay, thanks, Rohit. So if you look at, I have just import the package pandas, NumPy, as I discussed. I could not able to show you, sorry for that. And I import matplotlib and C1 for graph or plotting. Then I loaded the Titanic dataset. I just take this dataset, as I said, from Kaggle, and I loaded through pd.read.csv. I got the dataset, and Titanic head shows me the top 10 records. Here I can see that as whatever you discussed, like discrete, continuous, nominal, ordinal, you can see here. So passenger ID is a discrete data. Somebody was saying, why not it is a continuous data? But think of continuous data can have also a fractional value. Here we do not have a fractional. So I will treat that as a discrete value. Then SISP is nothing but a sibling spouse. So if you see here sibling spouse, this is also discrete because it is 103. How many count? How many number of kids you have? Or do you have a spouse or not? So that's a discrete value, right? Then numerical continuous is fair. So what is the pair? 7.25, 71. These are all numerical continuous. So similarly, the nominal are name, sex, ticket, embark, survive. So these values order doesn't impact my data set, right? Or my result set when I go for ML modeling. And the categorical ordinals are P class. P class is nothing like your which cabin you are, like what class you are traveling. And the cabin is that whether you are into cabin or not. So let me execute this. I just imported that, then I just read it fresh. Okay, this 10 records you have. Then I just look into the SEP. So I have 891 number of rows or records and 12 columns in my data set. So let's understand the data. So to understand the data is called as exploratory data analytics. Okay. So first let me see the data set. How does it look? What is the shape? Like what are the, see, passenger ID. I have total 891 records and all 89 records having passenger ID. If you see here, I can find out who are having the missing value. So if you see certain data has 714, it means the rest of the record doesn't have the age. Or if you see cabin also, only this many people have cabin details. Or if you go to your embark also, only 2 people having they do not have that information. So 3 columns where some values are missing. Okay, through this I got it now. So next is I can see the distribution of the data. So if you see the describe will tell you the mean, standard deviation, how many percentage of people are there. So if I look at here, if you see 75% of people are like within 40 years, right? 38 years of age people are there. So that's one thing I can check from here. So most of the people are within that range. And the very few people are old, very old. So now if I design a histogram just to see the data visually, I can see that, okay, the age looks like fine. Little bit left side skewed, but looks like normal. It's like a normal distribution, and the fare is like, if you see the more fares are towards this 0. So it means that the fare rate is more higher at this side, like 200 or 400. That means the cabin people only 2 are there. So cabin price is more. But most of them are going through general classes, apart from some are into this other classes of it. So if you see this is why it is more higher side of it. So many people started from the parch. So with family, or sorry, the family part is going towards this one. Just a minute. So okay, this part shows about 0. 0 means many people has not going with the family. And if you see, this is how, like, how many siblings or spouse were there. Very few are sibling with spouse, or maximum them are alone. And how many people survived and which have not survived. So many people are not survived, which is 0, right? 0 is not survived, and very few people are survived. So this is why I get a sense of the data, how the each attribute or each feature here, each feature is distributed across the data set. Now, this is another technique to find out how many null I have. So if I see here, I get the same sense here. Like if I deduct from 1891 minus 714, total number goes by how many values, I can get the same null. So same other way, I can just find out number of null count. So I get 177 people have null, no age, 687 people don't have this Kevin details, and 2 record doesn't have this embark detail. So if I get the mean, so I can find it out that how many data set for each were missing. So if you see 77% of the total data set, this is the number of record which is mostly missing, right? Kevin is the highest number. Then certain near to 90% or 19% or 20% age is missing, and just 2% of embark data is missing. Now let's deal with these 3 data, the missing regions are. So look at missing data not at random. When it is not at random means I can very well relate something to it. So if you see what I did in this set, I can establish a relationship. The people who survived could be asked for that information. So they probably, that's why missing data not at random. So the Kevin, since very few people survived, okay, so we do not have that info whether they're into Kevin or not. So it may be an idea that, okay, this way, it may not be 100% correct, but based on the domain knowledge when you apply to your, to your business problems. So I got this information that how many data set has null. So this is the 77%, same thing I'm getting here also, nothing new on that, right? So just looking into that way. So if you see here, this is what I infer. 1 means survived, okay? And 0 means not survived. So with particular that column, Kevin having null, out of survived people, only these many people having null. It means it is less than the non-survived. So when the person is not survived, this much of values, 87% of the chances, like a percent of missing value for that particular value. So that's how I infer a relationship. Okay, if somebody is survived, most of the time I find the data. But if somebody is not survived, I'm not finding the data. So that's what I can relate a relationship. Data is not at random. So missing data completely at random means these 2 records, right? Embarked, only 2 records are missing. And I cannot relate with anything like why these 2 records probably could not able to enter the data. I do not know any reason specific to this one. So this is data is completely at random. And I would like you guys to now search on or do research when you get this particular Jupyter notebook. Try to research on the same data set on missing data at random. Okay, so that you try to research by yourself. So now I came to know, okay, this is the different category of data. Now how to handle this. Imputing missing values. How to do imputing missing values. There are different techniques to do that. I will just talk only about age today. That will cover the end of this demo. So what you say is that if I look at the data set here, suppose I may go with if I go with mean of the age, so whatever the data set, I will get a mean and I will find out, okay, and that mean age I will apply to all missing. So what will happen? So this is just I'm just creating without that value, distribution of age missing, and here I'm using a mean technique, right? Wherever the value is null, empty, just use the age mean, whatever the age mean I will get, and just create the plot. So if I got this graph, so distribution of age missing. So if you see this, the right side, I filled, is it the age missing? So I filled with whoever, I fill that particular missing value with the mean of age, and I see that this is skewed up, right? Which is not actually good. So what is the best way then to fill that particular missing values for age column? Well, for that, I created a simple function with Mr., Mrs., Master, and Miss. And if you see, I just apply the title to every record. So this is one of the feature engineering technique. So you need to understand how to derive your results from it. So I did what? Wherever I get name with a name, I get a title, and I create a different group. I found out that, okay, these many people are Mr. 517 people are Mr. Mrs. are 182, Mrs. are 125, sorry, Ms. are 182, Mrs. are 125, Master are 40, and others are 27. So, and if I try to run the box plot just to see these are the outliers, there are certain values which are outliers, so I cannot go with the mean value. So, and I just group it. What I grouped it now, I took the mean of only Mr., I get one value, mean of only Miss, I get one value, Misses of 125 people, I get one mean, Master like that for 40, I get one mean. Now, a group that I got this value, right? For each group, what is the mean? So Master is 3.5, 21 is mean for only whoever misses, for them it is mean is this much. So what I will do, I will create another column, and sorry, I will not create another column. Whoever the value is missing, I will check that record is missing for Mr. or Ms. or Mrs. or Master, whatever. So if the record has a missing age, and if that person's title is Master or Mr., accordingly, I will apply that mean to that particular record. So that is the most accurate way of assigning the missing value for that particular record, right? If somebody's name is starts with Master, I cannot apply mean age if it comes around 40, right? So it is better to apply the mean age between all the Masters, so which is 3.5. So that's how I will deal with missing values when it comes to age. And then after applying, I could see the distribution looks like a little bit more, normal distribution. So that's how I will deal with your missing values for age. So for the embarked, probably I can check how many records are embarked, whether you wanted to use like whichever having more occurrence, wherever, then that I can use. Like here, I just find out how many people embarked from which value, S, C, or Q. So this is S, so I can use S everywhere whenever the embarked value is missing. And only certain records are, if just this is what I did just to see that apply value and just see Kevin, only so many records were missing for the Kevin, so I thought to drop it. But be aware, before you drop any feature, make sure that that particular feature is not impacting your algorithm. Okay, so if it impacts your algorithm, for that we have a concept called feature importance or feature selection. So that's a different topic out of this today's session. So be aware of it. Don't drop like simply since it is same. Okay, this is how it is. Most of the missing, I will drop it. It's not like that. Certain values are very less, but it has more impact on your model. Data imputation technique. That's how we do it. And there are some other techniques, interaction features. I may create a new feature if I find that a person is traveling with family and also having siblings or spouse, then definitely he is traveling with family, right? So I can create another feature called family. I created this feature called family, or sorry, this is family size. What is the total family size? I can find out. This one is myself. This is my, this is the, what you said, that the family count and the siblings one. So applying this, I may get a family size, how many total number of family in that particular group are traveling. I can find that. Or the other technique, as I said, I can find out whether I am, what you say, that a person is mother or not by then looking into the name, traveling with age, and age is greater than some value, then probably, okay, has mother or father. If it's a sex is male, is traveling with mother or traveling with father, probably you can find it out there. So different way you can think of the data when you are exploring it, and if it will helpful for you to predict the model better. So this is, if you go through this two things I will learn to this, that dealing with counts, how you deal with, I just said it, binarization technique you can go for, just run yourself, it is self-explanatory. And at the end, what I did, I just wanted to show you now very quickly. At the end, after doing all my feature acceleration, I just did this. I just use a logistic regression and then apply my data set to that fit model. A logistic regression because I'm predicting a person is survived or not survived. So I just applied the logistic regression, the simplest one. So fit it, and then I predict it, and I get these values, accuracy and ROC, AUC. So these are like the technique we use to find out the accuracy or performance of a model. ROC is like your receiver operating characteristics, area under curve. So these are different techniques. Just now, just ignore just like the highlighted line. These two are just to find out how my model is performing, and this is the output you get. The accuracy is near to 69%, and ROC and AUC is 73%. I did it. Now in this, I get this value. If you go quickly to another one, the same thing I executed here, but here instead of filling minimum value, what I did, I fill all the missing value with 0 here. There we are doing with mean, right? Here, if you see, here it is LAJ, not this one. There is a technique here. What do? You apply the minimum age with this value. Titanic age, fill NA, Titanic group by this value, right? You use this and run that particular model, this model, where you have the value. And you, without that, just fill with NA, like this way, 0, and apply that value. You may see a difference when you do that. And that's how you tweak with your features to get a better result for your accuracy or performance of the model. So any questions? I'm done. Thank you so much.
Yes, Sandip, I have some slides to show the audience. So meanwhile, they can put down their questions in the Q&A panel.
Absolutely. You just post your question on the chat channel, and by that time, Rohit will be showing some PPT, and I will be happy to answer. If I can't answer, just post your question to our Facebook page. I will definitely answer to all your questions. Thank you.
Okay, first of all, thanks a lot, Sandip, for your time. I'm sure everyone enjoyed that session. So if you have any questions, like Sandip said, beyond this webinar, you can always write to us in our Facebook groups and LinkedIn groups. Our speakers will definitely answer, and if they are not part of it, we will send it to them and we will definitely get an answer. Do not forget to join our Telegram group as well. As I mentioned, SQLMaestros Learning Solutions earlier, we have the masterclasses that are going on right now. We have Satya Ramesh taking 2 classes, one on T-SQL and SQL Server database administration. So do enroll in these classes. We have, of course, a popular masterclass by Amit Bansal on SQL Server performance tuning. So these 3 are the masterclasses that are remaining. Do enroll yourselves in these. We have the performance tuning video course that is coming out shortly in March, but you can always pre-register right away to get a discount. We have the Hands-On-Labs, which is a unique way of learning. Since you are all DPG members, we have a few demos that you can try out for free, and then you can choose to subscribe if you want. We have the learning kits that are based on Amit Bansal's performance tuning masterclass. You can check them out. If you are in need of SQL Server health check, you can always write to us at contact@SQLMaestros.com, or you can visit www.SQLMaestros.com, where you can find all these details. Like I mentioned, Data Platform Summit 2019 pre-cons. We will have 3 days of pre-cons and 18 pre-cons spread across these 3 days. We have announced 14 of them, all by popular speakers worldwide. We have Peter Maheshwarinath. All of these speakers, they will be taking sessions on Power BI, Azure, data science, and SQL Server. So do go through all these sessions and do register yourselves right away. It's just 3 more days to go to avail the super early bird price. After that, on March 1st, the price will increase. So do not forget to register. Even if you're not sure which pre-con you want to attend, you can block your seat, and then later you can choose the pre-con that you want to attend. Same goes with the summit. The price increases on March 1st, so do register. And we have also sent you all the discount code, the pre-registered people and our alumni. So you can always use the discount code and register. So for the people who are joining us for the first time today in the webinar, we also have Data Platform Days, which are full-day in-person events that we do at Microsoft offices throughout India. Our upcoming in-person events are happening in Bangalore and in Hyderabad. In Bangalore, it will be on March 2, and in Hyderabad, it will be on March 9. So Data Platform Day started following a new format since the year's beginning. We will have parallel tracks on Azure, data science, business intelligence, and SQL Server database administration and development. So it'll be a full day event, back-to-back sessions in parallel groups, and it is absolutely free. You do not have to pay anything. You can you're all welcome to attend at Microsoft offices. So visit dataplatformgeeks.com/events and you can register yourselves right away. And registration is mandatory, of course. That's it from me. Thanks a lot for all your time. This webinar will be recorded. I mean, it has been recorded and it will be updated shortly on our YouTube channel. That is youtube.com/SQLServerGeeks. Do not forget to subscribe to that. And we have posted a webinar pic on our groups, LinkedIn and Facebook groups. Please do not forget to give your feedback to us. That will really help us improve in the upcoming webinars, and of course the speaker too. So do join these groups and do give us feedback. Once again, thanks a lot for joining us, and thank you, Sandip, for your time. You can take your questions now.
If you guys any question, you can post in the comment. The silence is either you got everything or you got nothing out of it. No problem. So go through this. The presentation will be sharing in email. So go through that and ask your question later and in our LinkedIn or Facebook page, and I will try to answer them.
Yes, Sandip. So I don't see any questions. So once they post any questions in the groups, I'll ping you.
All right.
All right. Thanks a lot, Sandip. Again, once again.